Water and its solutions. Introduction. In an aqueous solution, ionic compounds are completely dissociated into ions. For example, an aqueous solution of barium nitrate, BaNO3 contains Ba2+ ions and NO3- ions. If aqueous solutions of ionic compounds are mixed, some ions may interact to form an insoluble product called a precipitate. For example, if aqueous solutions of barium nitrate and sodium sulfate are mixed, insoluble barium sulfate will precipitate. The complete formula equation for this reaction is written as follows: BaNO3 aqueous plus Na2SO4 aqueous yields 2NaNO3 aqueous plus BaSO4 solid. The barium sulfate is a white precipitate. Its formation as a result of mixing two unknown solutions could help you to identify the two reacting solutions. In this chem lab, you will work with the aqueous solutions of 6 unknown ionic compounds. By observing the solutions and their interactions, you will be able to determine the identities of the compounds. Lab prep. In preparation for this lab, make 100 milliliters each of 0.100 molar solutions of sodium carbonate, sodium iodide, copper 2 sulfate, copper 2 nitrate, lead 2 nitrate, and barium nitrate by adding the following masses to sufficient distilled or deionized water to make 100 milliliters of solution. 2.86 grams of Na2CO3, decahydrate. 1.60 grams of NaI, 2.50 grams of CuSO4, pentahydrate, 2.42 grams of CuNO3 trihydrate, 3.31 grams of PbNO3 2.61 grams of BaNO3 You will be investigating the following problem. What are the identities of 6 unknown aqueous solutions? Objectives. The objectives of this lab are: 1. Observe the interactions of the aqueous solutions of 6 compounds. 2. Interpret the results of the interactions and use the results to identify the solutions. Materials. Here are the possible materials you will need for this lab. 96 well microplate. 10 milliliters each of 0.1 molar solutions of sodium carbonate, sodium iodide, copper 2 sulfate, copper 2 nitrate, lead 2 nitrate, barium nitrate, identified only as A through F. 6 microtip pipettes, labeled A through F. 15 toothpicks. Distilled water in a rinse bottle. And your chemistry journal. Alternative materials may be used for this lab. You may substitute other solutions as long as sufficient insoluble and differentiable products result. Safety. For your safety, wear an apron and safety goggles. Wash your hands thoroughly after performing the lab. Some of the solutions are toxic. To dispose of lab materials correctly, use code J to dispose of lab materials. Collect all chemical solutions, precipitates, and rinse solutions in a polyethylene dishpan or similar container devoted to that purpose. Retain the solutions until the end of the period or day. In the fume hood, set up a hot plate with a 1-liter or 2-liter beaker. Pour the collected solutions into the beaker. Turn the hot plate on low and allow the beaker to heat with the hood running and the hood door closed. The liquids and volatiles in the mixture will evaporate, leaving dried chemicals. Allow the beaker to cool. Continue to add solutions and waste until the beaker is 2/3 full. Treat the waste as heavy metal waste. Dispose of the beaker and its dry contents in an approved manner. Procedures. For this lab, please follow these procedures. 1. Enter the data and observation table in your chemistry journal. 2. Obtain a 96 well microplate. To produce all the combinations of solutions, you will be using only the 15 wells in the upper corner. 3. Use the appropriately labeled microtip pipettes to place 3 drops of solution A in each of 5 wells in the first horizontal row. Three drops of B in each of 4 wells in the second row. Three drops of C in each of 3 wells in the third row. 3 drops of D in each of 2 wells in the fourth row. And 3 drops of E in 1 well in the fifth row. The first letter in each box in the table in Data and Observations shows the arrangement. For your second additions, use the appropriately labeled microtip pipettes to add 3 drops of the solutions to the same wells to obtain the combinations shown in the Data and Observations table. Thus, you will place 3 drops of solution B in the single well in the first column, 3 drops of C in both of the wells in the second column, and so on up to the fifth column, to which you will add 3 drops of solution F. You have now created all the possible combinations of pairs of solutions in the wells. Five, stir the solutions in each well, using a clean toothpick for each. 6. Place the microplate on a white surface and look down through each well to detect the presence of a precipitate. Cloudiness is evidence of a suspended precipitate. Repeat the procedure on a black surface. Record in your data table the color of any precipitates. If no precipitate is formed, write NR, meaning no reaction. Analyze the following information and write your conclusions in your chemistry journal. 1. Formulating models. Write balanced equations for all 15 possible double replacement reactions, regardless of whether they actually occurred. Show both possible products in each case. If the 2 possible products are the same as the 2 reactants, you can rule out the possibility of reaction, so write NR, no reaction, after the equation. 2. Classifying. Use a handbook of chemistry to find out the colors of each of the products and whether they are soluble or insoluble in water. 3. Drawing conclusions. Identify the 6 solutions by relating your data and observations to the predicted colors and interactions. Assume that the color of an aqueous solution is generally the same as that of the corresponding solute compound, except that solutions of white compounds are colorless. Read the following information and record your responses in your chemistry journal. 1. Explain in general terms the reasoning you used in your identification process. 2. What are some other methods you might have used to identify the solutions? ChemLab findings. Analyze and conclude. 1. CuNO3 plus CuSO4 yields CuSO4 plus CuNO3 NR. CuNO3 plus BaNO3 yields CuNO3 plus BaNO3 NR. 2CuNO3 plus 4NaI yields 2CuI plus I2 plus 4NaNO3. Note that this is unexpected. Students will probably write CuNO3 plus 2NaI yields CuI2 plus 2NaNO3. CuNO3 plus PbNO3 yields CuNO3 plus PbNO3 NR. CuNO3 plus Na2CO3 yields CuCO3 plus 2NaNO3. CuSO4 plus BaNO3 yields CuNO3 plus BaSO4. 2CuSO4 plus 4NaI yields 2CuI plus I2 plus 2Na2SO4. CuSO4 plus PbNO3 yields CuNO3 plus PbSO4. CuSO4 plus Na2CO3 yields CuCO3 plus NaSO4. BaNO32 plus 2NaI yields BaI2 plus 2NaNO3. BaNO32 plus PbNO32 yields BaNO32 plus PbNO32NR. BaNO32 plus Na2CO3 yields BaCO3 plus 2NaNO3. 2NaI plus PbNO32 yields 2NaNO3 plus PbI2. NaI plus Na2CO3 yields Na2CO3 plus NaI, NR. PbNO32 plus Na2CO3 yields PbCO3 plus 2NaNO3. 2. Reactants: copper 2 nitrate, blue; copper 2 sulfate, blue; barium nitrate, white, colorless in solution; sodium iodide, white; lead 2 nitrate, white; sodium carbonate, white. Products: copper 1 iodide, brown-white, insoluble; iodine, I2, brown in water, insoluble; copper 2 carbonate, blue-green, insoluble; barium sulfate, white, insoluble; barium iodide, colorless, soluble; barium carbonate, white, insoluble; sodium nitrate, white, soluble; sodium sulfate, white, soluble; lead 2 sulfate, white, insoluble; lead 2 iodide, yellow, insoluble; lead 2 carbonate, white, insoluble. Copper 2 iodide, an expected product, does not exist. Instead, copper 1 iodide and elemental iodine are formed. 3. A is copper 2 nitrate, B is copper 2 sulfate, C is barium nitrate, D is sodium iodide, E is lead 2 nitrate, F is sodium carbonate. Apply and assess. 1. Students should explain that they made observations that allowed them to relate information in a logical way and to rule out possibilities so as to identify the various precipitates and solutions. 2. The original 6 solutions might have been evaporated to test for crystal form and color. Flame tests also might have been done. Data and observations. Assuming solution A is copper 2 nitrate, B is copper 2 sulfate, C is barium nitrate, D is sodium iodide, E is lead 2 nitrate, and F is sodium carbonate, the grid should look as shown.